Hey guys, in this video we're going to talk about finding the slope. Okay, so in the last video we used tables to graph lines. So I gave you, or you chose some x values and that produced some y values with the rule that was given. Now what's kind of cool is that a line, last time we looked at finitely many points on a line, right? We took 3 x values, we plugged them into a rule, and we got out 3 y values. But in reality, a line has infinitely many points because we can choose infinitely many x values to plug into a rule. So that's just an interesting little thing there. One really nice tool that we use when we're looking at graphs is the Desmos Graphing Calculator tool. And you can find that by just Googling Desmos Graphing Calculator. And I have it as a little app on my iPad, but this is what it looks like. This is what should come up when you Google it. And you can put lines in here, so like the rules, like y equals 2x plus 1, tells me for every x value, we're going to multiply it by 2, then we're going to add 1 to get our corresponding y value. And if you move along the line, you can see that there are infinitely many values on this line of x and y, x comma y. So anyway, that's what we did last time. So we randomly chose some x values, some nice x values, maybe 0, 1, 2. Again, there are infinitely many x values we could choose, but just for the sake of being simple, we can choose these 3. And then what we did was we plugged in the corresponding x values into our rule for x, and then we evaluated to get y. So in this case, when we plug 0 into our rule for x, we get 2 times 0 is 0 plus 1 is 1. So an ordered pair on this line would be 0, 1. And we could even confirm that by seeing it right here. We can literally click on it, 0, 1, that point is on the line. Okay, so that's how we got our ordered pairs. So with 1, we would do 2 times 1 plus 1, and that would give us an output of 3, so that would be 1, 3. And then we could do 2 times 2 plus 1, and that would give us 5. So that would give us 2, 5. So all of these points are on the line. You should check on Desmos to confirm that's the case. Now that's all nice that we can do that. We can put in x values and get out y values. But there's a shortcut to graphing lines that we're going to talk about. And the first thing that we need to know before I teach you the shortcut is, and you've probably seen this before at some point in high school if you took math in high school, but if you haven't yet, that's fine too. The first thing I'm going to teach you is something what's called slope, and then I'm going to talk to you about a y-intercept. So the first thing we're going to talk about is slope. And slope, it's what you think of, like when you go skiing, or, I've never been skiing, but when you think about people going skiing, you think of them going down slopes, going down mountains. That's how I think about slope. So what slope measures mathematically, or what slope does mathematically, is it measures how steep your line is. So for instance, this has a big slope because it's fairly steep, right? If you were to walk up this thing, it would kind of make you pant a little bit, get a little out of breath. So that has a big slope. This has a not so big slope because it's not as steep, right? If you were to walk up that mountain, it would probably be easier. So slope is a number, okay? And it measures how steep a line is. That's all it is. We're going to talk about some, how useful slope can be for us. Alright, so now we need to talk about 3 different types of slope. Positive slope, remember slope is just a number that we associate to a line, okay? Positive slope means that if you were to put somebody on the left of the line, that, if you were to put somebody on the line going from left to right, they would be walking upwards. That's what positive slope means. So if you were to just place them on the line, walking from left to right, they would be going upwards. That's positive slope. Now, on the other hand, negative slope means if you put someone on that line and they start to walk from left to right, they're moving down. Okay, so I like to think of positive slope as you put somebody on that line and they're walking up a mountain. I like to think of negative slope as you put someone on that line and they're walking down the mountain, right? Because you got to go from left to right. He can't go that way because that's from right to left. He has to go from left to right. So positive slope up the mountain, negative slope down the mountain. Zero slope is completely flat, so there's no steepness at all. That's why a slope of 0 is 0. It's literally not steep at all. So Texas or whatever, Kansas, any kind of flat place have 0 slope. We're not walking up or down a mountain. It's just completely flat. Alright, so let's do some practice. Identify whether the lines have positive, negative, or 0 slope. So we're not counting the x and y axis. This is just always there. That's not a line. But I am going to do the lines in green. So let's look at this first line right here. If I were to put somebody on here and he starts walking from left to right, is he going up, down, or neither? Well, he's going neither. It's completely flat. So this is 0 slope. So 0 slope. Now, what about here? Well, that's 0 slope too because it's flat. So this is 0 slope. If I put somebody on this line right here, walking from left to right, is he going up or down a mountain? Well, he's going up a mountain, so that's a positive slope. If I put somebody over here, and he starts walking from left to right, is he going up or down a mountain? He's going down a mountain, so this is a negative slope. This guy, from left to right, he's going up a mountain. It's not as steep as this mountain right here, but he's still going up, so it's a positive slope. And then these two, it's not flat, but it doesn't really have any steepness either, so we're just going to put a question mark there for now. So this line and this line were 0 slope. This line were positive slopes. And this was our only negative slope there. Alright, so the letter M means slope. When you see M, you should think slope. And the steeper the slope, the bigger the number M. So we have a bunch of lines graphed here. M equals 0 is the green one, so you can see that that's 0 because it's completely flat. Now 1/2 is in yellow, and so this is positive because he's walking up the mountain. But notice that as M gets bigger and bigger, the mountain gets steeper and steeper. The steepest one is at M equals 4, so you can see that if you put that guy on there, he's going to have a hard time walking up versus this guy right here. You see the black and the yellow, all of these have positive slopes except for 0, but how steep the slope is depends on how high the number is. So 4 is the highest number out of all of these, so it gives the steepest mountain. That's how you can think of slope. Alright, so let's do some ordering from smallest to largest. Again, the x and y axis are not lines, so I'm just going to do these in orange so we can just know to ignore them, I guess. So, first of all, the smallest slope is going to be a negative slope if there is one. So do we have any negative slopes? Well, if I'm going to put everybody on a mountain. Okay, so here's a mountain, here's a mountain, here's a mountain. Doesn't matter where I put them, but each guy goes to a line. Okay, now with you, that's pretty easy to see. There's no steepness. If he moves left to right, I'm not getting any kind of steepness, so that's a 0 slope. So M equals 0 for 0 slope. Now, what about this guy up here? Is he walking up or down a mountain? Because he's going from left to right. Remember, he's going this way, in that direction. So he's going up a mountain, so that's a positive slope. This guy right here on line S is going down a mountain when he walks from left to right, so M is negative. And then finally, this guy right here is walking up a mountain going from left to right, so he has a positive slope. Okay, so from smallest to largest, there's only one negative slope, and that's the purple line. So S is going to be the smallest slope. It's negative. And then following that, think of a number line. So we have negative slopes, we have 0, we have positive slopes. Next comes 0, right? So the next line is going to be line U with the 0 slope. Then come the positive slopes. Now, the biggest number is going to be the steepest line. So this guy's positive and this guy's positive, but which one is more positive? Which mountain is steeper? Well, it's got to be the red one. That guy's steeper, so that's the highest slope. So that means that green comes next, which is R. And the biggest slope is going to be T, which is red. Cert. So those are my slopes from smallest to largest. Alright, so let's talk about what slope means algebraically and graphically. So slope is rise over run. Remember I said slope was m, so I'm going to use m a lot for slope. Just know that those two things mean the same thing. Again, m is just measuring how steep a line is. That's literally what it does. And to put this numerically, to say how steep is a line with numbers is to say rise divided by run. Rise means how much a line moves up or down, and run means how much a line moves left or right. So rise over run. For example, if you have a line that has a slope of 2 over 3, what is the rise and the run? Well, 2 is in the top, so that's the rise. So 2 is the rise, and 3 is in the bottom, so that's the run. So find the slope and connect the dots. So this is how we do it, okay? We start at one of the dots. I'm just going to choose the left. And we're trying to see how much do I have to rise and how much do I have to run to get to the next dot. So if I start here, I have to rise 1, 2. So I rose plus 2. And then to get to the other one, I have to run 1, 2, 3. So I went 2 in the positive y, and then 3 in the positive x. So rise over run. So my rise is positive 2 over positive 3. And a positive 2 divided by a positive 3 is just 2 over 3. So this is our slope. So that's our slope. Now, you can see that the rise over run's not going to change. So like if I start at this point and I go to the next point, I rise 1, 2, and then I run, so that was positive 2, and then I run 1, 2, 3, plus 3. So the rise over run is the same. Now another way, I want to show you how to do this going the opposite way. So like, let's say we don't start at the leftmost black point. Let's say we start the top one over here. We can still do rise over run and get the same answer. Watch. Let's say that I want to go from this point to this point, okay? How much do I have to rise and run? Well, rising, I'm actually rising down, if that makes any sense. So I'm rising down 1, 2. So I go down, which corresponds to a negative 2. And then I go to the left, 1, 2, 3. So I go minus 3 because left and down are both minus. So when you do rise over run, you do negative 2. Let me do this in red, actually. You do negative 2 divided by negative 3, and a negative divided by a negative is a positive. That's how the positive comes to be. Now, and this is important, okay? So, just wrap your head around how we can get the same answer by starting at different points. It doesn't matter which point you start at and which point you end at. For example, what if I choose to start here and end here? and like cut out the middleman. How much do I have to rise? I have to rise 1, 2, 3, 4. Is that 4? Yeah, plus 4 to get level with this one. And then I have to run 1, 2, 3, 4, 5, 6. So I went 4 up and 6 to the right to get from this point to this point. But guys, what's happening here is the following. We get, we're basically getting similar triangles, because originally we did this, but now we're just kind of making the triangle bigger, if you can see that. But the rise over run, so we have rise plus 4, run plus 6. Guys, if I simplify by 2, if I divide top and bottom by 2, I get 2 over 3. Isn't that cool? So you can start at any point and end at any point, and you'll always get the same slope. So this is the slope, 2 over 3. Let's do this one. So I'm just going to start here and end here. It's the easiest way. I mean, you can start there and end here if you wanted to. You could even start here and here. You could start here and here. You're going to get the same answer, guys. So I'm going to start here and choose to end here. All right. So I'm going to rise. I'm going to rise 1, 2. So I went up 2. So plus corresponds with up. Then I go to the right 1. So right corresponds with plus. And so my rise over run, I went up 2, and then I went to the right 1. So rise over run, and a positive 2 divided by a positive 1 is positive 2. So this is my slope. My slope is 2. That measures the steepness of my line. Now if you connect the dots here, that's our line, and we have a steepness of 2 associated with it. Over here, our slope was 2 over 3, which is a smaller number than 2. And so we expect this to be less steep, right? And it is the case. This is definitely steeper than this, right? This guy has a smaller slope than this guy, all right? So slope, rise over run. Now, let's connect the dots here. We should get a negative slope, right? Because if I put a guy on the mountain, from left to right, he's walking down. Let's see if I get negative slope with rise over run. So I'm going to start here and end here. Seems like a reasonable thing to do. So I'm rising down 1, 2, 3 to get level. So I went down minus 3. And then I'm running 1, 2, 3, 4 to the right. So I went plus 4 to the right. So my rise over run, my slope, is negative 3. I went down 3, and then I went to the right 4. Now a negative divided by a positive is a negative, so my slope is negative 3 over 4. We expect it to be negative because if we put a guy on here, he's walking down the mountain. Alright, find the slope and connect the purple dots and the red dots. Okay, so we have 2 different lines here. We have a line that goes through the purples, and we have a line that goes through the red. Now, which of these lines, think about this, which of these lines do you expect to have the bigger slope? Which one do you expect to have the bigger slope? Well, they're both going to have negative slopes. If you put a guy on here, they're both walking down the mountain. This guy is going to have a more negative slope, which means that the number itself is going to be smaller. So like the steepest in the negative direction is going to have the smallest slope, which is opposite of what we have for the positive direction. Okay, so let's go ahead and do rise over run. So for purple, I can, I'll start here and end here. So I rise 1, 2, 3, 4, so I went up 4, and then I went to the left 1, so minus 1. So my slope for the purple is rise 4, run negative 1. A positive divided by a negative is a negative, so my slope is negative 4 for this guy. Now, what about the red? So the red, I can, again, you can start wherever you want. I'm going to start here. I'm going to start here and end here. So I'm rising -1 and I'm running to the right +1. So negative corresponds to down, positive corresponds to the right. So my slope for this guy is -1 over +1, which reduces to -1. And this is what we expect. This guy has the less steep slope, so it's going to be less of a negative number. All right, let's try this one. So for the red, if I start here, I'm rising 1, so +1, and I'm running 1, 2 to the right, +2. So my slope is +1 over +2, which is just 1 over 2. My slope is 1 over 2. Connect the dots, and that makes a line. Again, there are infinitely many points on this line. I just have 3. Right? There's an infinitely many number of points, though. With the purple, to get from here to here, I'm going to rise 1, so +1. Then I'm going to run 1, 2, +2. So again, I have a slope of +1 over +2, which is 1 over 2. Connect the dots, and what do you think is going to be the case with these lines? They're never going to meet, right? If we were to just extend this line out forever, both of these lines, they're never going to meet. They're parallel lines. Their steepness is the same, okay? They have a slope of 1/2. All right, find the slope of the line. Okay, so now we have 2 little points here that I'm going to use just for convenience. And so I'll start at this one and I'll go up 1, 2. Okay, so I went up 2. And then I'm going to go to the left 1, 2, 3, 4, 5, 6 until I get to that other point. So I went -6. So rise is +2, run is -6, reduce by 2, divide top and bottom by 2 to get -1 over 3, right? Positive divided by negative is a negative, reduce top and bottom by 2 to give us a slope of -1 over 3. And it makes sense that it's negative because there's the guy on the mountain going from left to right, walking down. Okay, what about this one? So there's no points drawn, but we can definitely draw our own. That's no problem. We just need 2. How about these 2? That's pretty easy. So to get from this one to this one, I can go up 1, so +1. Then I can go the right one, +1. So my slope is just 1 over 1, which is 1. Okay. Alright, now we need some nice points. I don't want to use a random point like this because I don't really know where he is, but I like points on the corners of the boxes. Those are good points. This is not a good point because he's not on a corner of the box. I like this one. That's a good point. And I like that one. So I'm going to start here, and I'm going to go up 1, 2, 3, 4. Okay, I went up +4. And then I'm going to run 1, 2, 3, 4, 5. So I went to the right +5. So my slope, rise over run, is going to be +4 over +5, which is just 4 over 5. That is my slope. Alright, again, you want to pick out some nice points that intersect the corners of the boxes. I like that point. And I like this point. Those are corners of boxes. So if I start at this one and go up, I go up 1, 2, 3, 4. Okay, so I went up 4, +4. And then I'm going to go to the right, 1, 2, 3, +3. So my slope, my rise over run, is +4 over +3, which is just 4 over 3. Okay, so we can do other things other than rise over run. We can use this formula right here, and it's it is rise over run. It's just in formula form, and I'm going to show you why. But so there's a formula. It's right here. And what does it mean? Well, if you know 2 points on a line, if you know they're x comma y, then those 2 points are represented as x1 comma y1, where this is our first xy coordinate. And then the second one is x2 comma y2, where this is our second xy coordinate. This is the formula. So we just subtract the y minus y over x minus x. And then this is how we say it in words. We say the slope, which is m. So slope, which is m, is equal to the change in y. That means the y2 minus y1 divided by the change in x. That's x2 minus x1. So let's look at using this formula. So our formula, I'm going to write it down here. y2 minus y1 over x2 minus x1. So we want to find the slope of a line that goes through these 2 points. Okay? We only need 2 points to define a line. Alright, so this is valid. This is good. Now, you need to label point 1, point 2. Which one you choose for point 1 and which one you choose for point 2 does not matter. It really doesn't. I could choose this as point 1 and this is point 2, or I could choose this as point 1, this is point 2. It doesn't matter. I'm going to choose this one as point 1, so I'm going to call this 2x1 and this 5y1. That means first point. The ones mean first point. Second point is x2, y2. Okay? And all I'm going to do is plug in these numbers into this formula. So my slope is going to be y2, which is 9, minus y1, which is 5, divided by x2, which is 3, minus x1, which is 2. Okay? So on top, 9 minus 5 is 4. 3 minus 2 is 1. So the slope is 4. Now, I could have seen this with the graph too. I could have gotten the same result from the graph. So let's plot these points so I can show you. So x1, y1 is at 2, 5. So 1, 2, 1, 2, 3, 4, 5. That's our first point. And then our second point is at 3, 9. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, way up here. Okay, so those are the points. And if I do rise over run, I go up 1, 2, 3, 4, so up 4, and then I run 1. So that is plus 4 over plus 1, same thing as a formula. Alright, let's use the formula again. So I'm just going to call this one x1, y1, and I'm going to call this one x2, y2. And our formula says our slope, or the steepness measure, is y2 minus y1 over x2 minus x1. So y2, we get negative 2 minus y1 is 3 over x2 is 4 minus x1 is negative 5. So remember, when we have double negatives, that becomes a positive. So that becomes a positive there. So on top, negative 2 minus 3 is negative 5. And on bottom, 4 plus 5 is 9. So our slope is negative 5 over 9. Okay, let's try this one. So I'll call this x1, y1. Call this x2, y2. Using the formula, m equals y2 minus y1 over x2 minus x1. Just plugging these numbers straight in. y2 is 7, so I get 7 minus y1 is 1 over x2 is 5 minus x1 is 3. On top, 7 minus 1 is 6. On bottom, 5 minus 3 is 2. 6 divided by 2 is 3. So that is our slope, 3. Okay, let's try this one. So I'll call this x1, y1. And again, I could have easily called that x2, y2, and this other one x1, y1, but doesn't matter. So our formula, we have y2 minus y1 all divided by x2 minus x1. So y2 is negative 18, y1 is negative 3, over x2 is negative 4, minus x1 is negative 10. So notice that we have double negatives here, which becomes a positive. So I'm just going to make that a positive. And down here we have them as well, so that becomes a positive. And if I want to, I can rewrite this as negative 18, positive 3. Actually, I'll do that in red so you guys can make the connection. Okay. So on top, negative 18 plus 3 is negative 15. On bottom, negative 4 plus 10 is positive 6. And I can simplify this by 3. So dividing top and bottom by 3, I get negative 5 over 2. And that is my slope. Alright, so it says determine the slope with the formula. Confirm your answer with rise over run. So we need to pick out 2 points to use the formula. So how about this one, that's a corner point, and that one's a corner point. Okay, now we actually have to find the ordered pair for the numbers to actually use the formula. So this point, if we look at the middle and we see how much it goes in the x direction, we go out 1, 2, 3, 4 in the x direction, and then up 1, 2, 3 in the y direction. So that is we can call that x1, y1 if we want to, our first point basically. Now what about our second point? Now our second point is down here, so I go positive 1 in the x, negative 1 in the y, so that is at positive 1, negative 1, and that can be our x2, y2. Okay, so now we have ordered pairs and we can use our formula. So our formula is y2 minus y1 over x2 minus x1. So y2 is negative 1. So we have negative 1 minus y1 is 3 over x2 is 1 minus x1 is 4. So on top, negative 1 minus 3 is negative 4. On bottom, 1 minus 4 is negative 3. And the two negatives divide out to become a positive. So this is positive 4 over 3. We can also see the guy on the mountain, okay, confirming that that's positive. Okay, so that's it. We can also use rise over run, so we can go up 1, 2, 3, 4. So we went up 4. And then we ran 1, 2, 3. So positive 4 over positive 3. So that is confirming our answer there. Okay, let's do this one. So we need to label our points. How about the ones that are already shown there? So this point right here is x equals 6, because we can see that it goes out 6 in the x direction and up 2 in the y direction. So that's our point there. And I'll call that our first point, x1, y1. This point right here, we're not moving horizontally in the x direction, but we're going up 4 in the y direction. So x is 0, y is 4. So that could be x2, y2. And then our formula tells us y2 minus y1 over x2 minus x1. So y2 is 4 minus 2 over 0 minus 6. Just subbing these values in from our points. 4 minus 2 is 2. 0 minus 6 is minus 6. If we divide top and bottom by 2, this reduces to 1 over negative 3. So that is our slope. We can also see this rise over run. So if we start at this point and go to this point, or vice versa, it doesn't matter, but we go down 1. Wait, is that 1? Yeah, 1, 2. Okay, so we went down minus 2. And then we go to the right, 1, 2, 3, 4, 5, 6. So plus 6. So rise over run is equal to negative 2 over positive 6, which again reduces to negative 1 over 3. So that checks out.